In this video we're going to take a look at the Matplotlib package from Python. We're going to begin by creating a simple graph, and then we're going to enrich it by updating the titles, the legends, and also the axes. We're then going to look at how you can customize this by adding multiple graphs to a single canvas. We're going to take a look at subplots, and then we're going to conclude by looking at some useful styling tips for you to get started with Matplotlib. If you like this video, please give it a thumbs up, and also consider subscribing to the channel for more videos on Python. I'm going to begin by importing Matplotlib and NumPy into our workbook. It's important we specify the Pyplot package from Matplotlib, as this is what we'll be using, and by convention this is imported as PLT. We're going to begin by plotting a simple XY graph. I will use NumPy to create an array of x values from 0 to 9 with a range, and then a y array which is simply 2 times x. We can visualize our two arrays into a line graph by using the plot method from Matplotlib and passing in our x and y arrays. We can now see a basic graph below using the default formatting from Matplotlib. If you're using Jupyter Notepad like I am, it's likely you'll see the same result. However, if you're learning by using an IDE and a PyScript, then you will need to add a further line of plt.show to render the graph image to your output. So with our first graph created, let's begin editing it with a title and labels. Throughout this video, you will see me repeatedly copy and paste the old code into a new cell, making an update and then running the cell. I'm doing this because all Matplotlib graph instructions must be executed at once to see the progression of code, cell by cell, and the output. I will also save this notebook to GitHub, where you can find a link in the description below. We can add our graph title using PLT title, so I will use my title. And we can do the same for our x and y axis using x label, which I will call x axis, and then y label, which I will call y-axis. Returning this cell will show us a graph with title and labels, so it's pretty simple so far. One thing you may notice is that our line graph is slightly centered and the x and y axis start with a negative number. We can change the x and y limits of our plot using the plt xlim, passing in two arguments for where we would like x to start and end. So I'm just going to use 0 and 10. Then for the y-axis, I will use ylim, passing in 0 and 20. We can now see our graph starts at 0, 0 in the bottom left, and the xlim and y property can also be really useful when trying to zoom into a graph to highlight a specific area, as we will later see in this video. If we'd like to save our plot to an image for exporting, we can do that with the plt savefig method, passing in the name of our file. You can also specify the exact directory as an argument if you'd like to save it somewhere else in your file system. So that covers the basics of using PLT to create and edit a graph. We're now going to look into the figure and axes that can be created with Matplotlib. The figure, as we will soon see, enables us to have a greater degree of control over our graph. We could begin by creating a figure with plt.figure, and this is going to create a blank canvas for us to begin adding our graph to. The canvas will remain blank until we add an axis to it. We can add an axis to our graph by first assigning the figure to a variable, and the convention here is to call it fig, and then we can create a new variable, axis, which is returned from calling fig.addAxis. And then within addAxis, we're going to pass in an array that takes in 4 values. So the first two specify where on the canvas we would like our axis to begin, and then the third and fourth values will specify the ratio of the height and width of our axis to the canvas. So if I put 0, 0, 1, 1, we will have an axis that starts at the bottom left of our canvas and takes up the full size of it. We will soon begin to play with these values as we create multiple axes on our canvas, but for now, feel free to play about with the third and fourth values to see how the ratio of the size of the axis can change. Changing the first two values will not make a difference to the canvas, as we only have one axis on our canvas, and there's nowhere relative for that graph to be located. We can then add our graph to the axis by calling axis.plot, passing in the x and y arrays we would like. We're now going to begin looking at how we can add multiple plots to a single canvas. I'll start by creating a new array with NumPy. I'll create A, which will be linearly spaced from 0 to 10 with 11 points, and then B, which is A to the power of 2. We will also have X, which is from 0 to 9 with NumPy arrange, and then Y, which is equal to 2 times X. I'm going to create a figure with PLT figure, but within the figure constructor, we can specify a couple arguments to customize our graph size and image quality. We can use the fig size argument to specify the size of our canvas, assigning the value with a tuple. And then we can also add the DPI argument, which stands for dots per inch, to configure the clarity of our graph. I'll create a graph which is 4 inches by 4 inches, and then use 200 DPI. Just bear in mind that the DPI will increase the RAM requirement of your program, so we'll want to be quite conservative in how we scale this number. Next, I'll add our axis as we've done before, and then plot A and B into our axis. The figure object enables us to add multiple axes to our canvas, and we can do that by simply calling add axes multiple times on the same figure. I'll create a new variable, axis_2, and call fig.addAxis. Within the addAxis method, I'll tell Matplotlib to place the graph near the middle of the canvas from 0.1 from the x-axis and 0.45 from the y-axis. I will also specify the ratio of 0.4 and 0.4 for the width and height, so the graph is a little bit smaller. I'll then call plot on both axes, so we will have A and B on the first axis and X and Y on the second axis. We can now see our second axis illustrated in our graph quite neatly. The axis definition we pass into our second axis is customizable for us to move the plot around. So if I change the height and width to 0.6, we can see this graph appear much larger, and it's also covering the other graph that we have. If I also change the positioning to 0.1, 0.1, the graph will shift towards that bottom left of our canvas. So have a play about with these to see how the location of our second axis can be moved around to develop your understanding. We can complete the formatting of our canvas by setting titles, labels, and limits on each of our axes. So early in this video, we did this by calling upon the PLT, and for our figure and axis, it isn't too different. As we specified 2 axes, we will have 2 separate graphs which we can format on our canvas. We do this by simply calling a set method on the axis. So for the main axis, I will call .set_title and pass in my dual axis. Then I will call set_xlim and set_ylim to change the x and y limits to 0, 10, and then for 0, 100. And then I'll also be able to label our x and y axis on our axis. For the smaller and the second axis, I'm not going to assign labels or titles, but I will change the x and y limits to 0, 10 and 0, 20 just so we can neaten the graph up. So that's how we can add a second axis to our canvas and how we can format them individually. Before we move further, I'm just going to quickly show a handy use case for showing a larger and smaller graph, and that may be to provide a close-up of our data. So for the smaller axis, I will simply change the plot to also use AB. So both graphs have the same data. However, I will change the x and y limit on the second axis to 0, 2 and 0, 10. And this is going to zoom in on our data for those first 2 x values. This can be used to illustrate a change in data from our graph or to highlight a key detail on the plot. In this section, we're going to look at subplots, which is another way we can create multiple graphs on a single canvas, however in a more organized manner where they're sitting next to each other. We can create side-by-side formations using plt.subplots. The subplots will return a figure and an axis to us in a tuple. When creating the subplots, we must first pass in the number of rows and columns of graphs we would like on our canvas. So for now, I'll pass in 2, 2, and we can see 4 empty graphs evenly distributed on our canvas. Let's look at how we can populate them. I'll start by defining some new arrays. So I will have a equals np.linspace, and then that'll be 0 to 10 with 11 points, and b, which is a to the power of 3. We will have x, which is 0 to 9 using a range, and y, which is just 2 times x. I'll create a new subplot of 1 row and 2 columns, so we have a total of 2 graphs. We can now begin to plot on these graphs, and we specify the exact axes to plot against by referencing the axes as an array. As we know, we have 1 row of 2 graphs, therefore the array position 0 will point to the first axis, and position 1 will point to the second. I'll call axis and then open square brackets 0 and then close square brackets to obtain the first axis, and call plot on this with x and y. Then I can call axis and then 1 within squared brackets to obtain the second axis, and I will call plot passing in a and b. We can now see our 2 subplots next to each other on the canvas. If I expand the number of graphs on our canvas to 2 rows and 2 columns and try to plot our 2 axes, we'll see an error that the axis we've tried to obtain is an array and not an axis object. As we can see below the error, we have 4 graphs on our canvas, and we must now point to 1 using a 2-dimensional matrix rather than an array. Therefore, the top left axis will be position 0, 0, the top right is 0, 1, and the same for the bottom left and right as 1, 0 and 1, 1. We can update our axes to call 0, 0 and 0, 1, and now we can see how we can plot against the top 2 graphs. One thing you may notice with our graphs is that the axis labels are a little close to each other. We can see 1000 is almost brushing the axis in the top left. We can automatically configure the layout to provide a little bit more margin to the edges by calling plt.tight_layout. With our subplots created, we can now begin to format each axis in a similar fashion as we had done with our axes earlier. So I'll select an individual axis by specifying the matrix position on our axes. Then I can call the set methods to format them. So I'll use set_title and just call it my title. We can now see the graph show its own title on our canvas. If we want to provide a title to the canvas itself, then we can use the figure object and call subtitle for super title. And I'll pass in just canvas title here. You can then take this further by adding labels to the axes and limits, as we've seen earlier in this video. In the last part of this video, we're going to look at how we can style our graphs to make them easier to read and to illustrate any details of our data. I'll start by creating a new array of data from 0 to 10 with linspace, a figure that is 3 by 2 inches with 300 dpi, and I'll add just a single axis. Using our array, I will now plot 3 lines onto our axes for x by x squared, then we'll have x by x, and also x by x cubed. If I return our figure, we can see these 3 lines. However, it isn't very intuitive for us to know which is which. We can improve our graph by adding labels to each plot to describe what they contain. So after each plot, I'll put a comma and the keyword label, followed by a string of what they contain. So that will be x versus x to the power of 2. Then I'll have x versus x. And lastly, I'll put x versus x to the power of 3. We need to make sure we call ax.legend within our cell to ensure the legend is showing the label and their colors as they appear on our canvas. Now by default, Matplotlib will do its best to place this legend so that it doesn't intercept the data on our graphs, and it's actually done a pretty good job for us. However, just for your understanding, we can also specify our own location using the loc argument in ax.legend, where we can describe the location such as upper right. Another approach could be to pass in a tuple that places the legend on the canvas using a relative position to the axes. So if I put 0, 0, this will place it in the bottom left. I can also add 1, 1, and that's going to move it to the top right. And then I'll finish this by putting 1.1, 0.6 to have it floated just right midway up the graph and outside of the graph. Have a play around with these numbers to build your understanding of how you can configure the legend, and also check out the documentation to understand the different descriptive positions that you can use. We're now going to look at a few ways that you can customize the plots you have in the graph. I'll start by defining x from 0 to 11 with linspace, and then I'll create a new figure and axes. I'd encourage you to do the same so you can build that muscle memory of creating graphs with Matplotlib. I'll also use the x and y limits of 0 to 12 and 0 to 150 as I plot x by x squared. We can then change the graph line by introducing a non-default color. I can use the color keyword argument, so that's color spelt without a U, and assign that to purple. And then I'll also provide a label of x versus x to the power of 2, and let's not forget to call ax.legend. What we can see is that we've slightly changed the appearance of our graph just by changing the color of that line. I'm going to add another plot, this time for x by x. If we want to increase the width of our line plots, we can do so using the line width argument. So I'll put line width equals 5 for the x squared plot. We can also just use LW to assign the line width, so I'll put LW equals 3 for the x by x plot. We can also adjust the line style with the line style argument, so I'll use line style equals dotted. And we can also abbreviate this argument to ls, so I will use ls equals dashed for the x by x plot. So we can now see how we've been able to change these graphs sort of visually by changing the line width and also the line style. Take a look at the Matplotlib line styles documentation for more detail on the various ways you can specify the line style of your graphs. With our line widths and styles sorted, I'll touch upon one last style guide to conclude the video, and that's markers. A marker will simply appear on our line for each data point that we have. So I'll start with the x by x squared plot. I'll make the line width 2 and the style as a dash so we can easily see our marker. Then I will use the marker argument to specify it as an x. We can change the marker size with marker size or ms as the argument. So I'll use ms as equal to 20. So they appear quite big. And then we can also change the edge of our color with marker edge color, which I will make blue. For the x versus x plot, I'll make the line width 1, using a dash for the line style, but this time I'll use the O as a marker. And I can make the outside of the O black with marker edge color equals black, and I can color the inside of the circle with green by using the marker face color. So that's why we have such long names for our marker colors, as we can specify both the edge color and the face color of them. We can now see how the data points are slightly different by the marker, the size and color. I'll just adjust the marker size of our X to 10 just to make it a little bit smaller, but also feel free to play around with these as you explore the different ways that you can style your graph. Also head to Matplotlib.markers documentation to see more detail on the ways that you can style your markers. So that concludes this video introduction on Matplotlib Pyplot. We've looked at how you can create different graphs and subplots. and how you can enhance them with styling and legends. I hope you found this video useful, and stay tuned for more videos on Python.